Straightness can be used to control the cylinder axis from bending. When straightness feature control frame is attached with dimensional tolerance, we can understand that straightness applies to the median line of the cylinder. Now let's look at applying straightness to a feature of size. Prior to the 2009 SME standard, straightness could be applied to any feature of size. In the 2009 standard, the rules were changed such that straightness can be applied to cylindrical features of size but not rectangular features of size. The figure below shows straightness applied at MMC to a cylindrical feature of size. We know that the straightness applies to the feature of size because the straightness tolerance is located below the size tolerance. The tolerance zone is a cylinder within which the axis of the pin must fall. Of course, since the axis is not a straight line, we call this imperfect line a derived median line. Since the straightness tolerance is called out at MMC, the size of the tolerance zone can vary. When the size of the part is 11, then the size of the tolerance zone is 0.1 diameter. As the size of the pin departs from MMC, we get bonus tolerance. This means that as the pin gets smaller, the size of the tolerance cylinder grows by the amount that the part is away from the MMC size. Let's assume the outside diameter of the cylinder is 9 inch. The 9 inch dimension is least material condition for the cylinder. Since straightness is applied at the maximum material condition, we get bonus tolerance. The bonus tolerance for this cylinder is 11 inch minus 9 inch. So we will get 2 inch. The 2 inch is the bonus tolerance and 0.1 inch straightness tolerance applied at maximum material condition. By adding bonus tolerance and straightness at the MMC, we get 2.1 inch, the total straightness tolerance available for if the part is manufactured at 9 inch outside diameter. When straightness is applied to the feature of size, it overrides the rule 1. Rule 1 states that part must not violate MMC boundary, that is perfect form at MMC. When straightness is applied to the feature of size, it gets virtual condition boundary. So the part should not violate virtual condition boundary, but it can violate maximum material condition boundary for this case. Let's calculate the virtual condition boundary for this part. The dimension at MMC is 11 inch. Straightness tolerance at the maximum material condition is 0.1. By adding 11 inch plus 0.1, we get 11.1 virtual condition boundary. Virtual condition boundary is nothing but outside boundary. This value is constant for this part. Note that the 11.1 inch virtual condition boundary is never violated. Applying straightness to the feature of size will result in a virtual condition boundary that cannot be violated. In this slide, straightness tolerance is applied to whole axis. As I said earlier, when the straightness feature control frame is attached with feature of size, then the straightness applies to the axis of the cylinder. So here the straightness controls the whole axis, which is an imperfect axis called derived median line. So the condition here is the derived median line should lie within the cylindrical tolerance zone of 0.1 inch diameter if the hole is produced at MMC. The 11 inch hole size is least material condition of the hole. Since straightness is specified at the maximum material condition, we are going to get bonus tolerance. The bonus tolerance is the actual size minus hole size at the MMC. So 11 minus 9, we get 2 inch diameter which is the bonus tolerance, and 0.1 inch dia at the MMC. So 2 plus 0.1, 2.1. For the hole produced at 11 inch diameter, we get 2.1 dia tolerance. So the derived median line, that is the axis of the hole, should lie within this 2.1 diameter tolerance zone. Let's calculate the virtual condition boundary for this hole. For internal features like hole, virtual condition boundary is innermost boundary. Here the innermost boundary is hole size at the MMC, which is 9 inch, minus straightness tolerance applied at the MMC, that is 0.1. So 9 minus 0.1, 8.9. So the 8.91 inch diameter is the virtual condition boundary, which is the innermost boundary for the hole. The part should not violate this virtual condition boundary. Let's see the difference between straightness applied at regardless of feature size condition and straightness applied at MMC condition. Here 0.004 inch diameter straightness tolerance is applied to the cylinder. Let's calculate the total straightness tolerance when the diameter varies from MMC to LMC size. For RFS condition, the geometric tolerance value remains the same for any increment of feature size. Whether the part is produced at MMC size or LMC size, the total straightness tolerance value is constant, as bonus tolerance is not applicable here. For RFS condition, the total straightness tolerance value is 0.004 inch. For straightness applied with MMC modifier, bonus tolerance is available. Let's assume cylinder outside diameter size is 1 inch. Here bonus tolerance is 1.02 inch minus 1 inch, that is 0.020 inch, and 0.004 inch tolerance applies at MMC condition. So the total straightness tolerance is 0.024 inch. For the part produced at 1 inch outside diameter, the axis must lie within cylindrical tolerance zone of 0.024 inch diameter. Let's see how to inspect straightness applied to the axis. First, size feature of the part is measured to verify it falls within its limits of size. Then, straightness verification of the size feature specified at MMC can be verified by placing the part in a functional gauge. If the part goes all the way in the gauge, then it is a good part and the part is acceptable. For straightness specified at RFS can be verified by taking differential measurements on opposite sides of the part with a dial indicator. This determines how much the median line varies from perfectly straight axis.